Okay, welcome back. First things first, I can't say anything about the exam because not everyone has taken it yet. So the moment everyone has, then I will talk about the exam. Okay. So I just want to review very quickly what we talked about last week after the exam, and we introduced confidence intervals, if you remember. And we are first dealing with confidence intervals for a proportion, right? Proportion pi. The formula was shown a couple of times. Basically, if you follow this prescription, nice things happen. You can construct what's called a 95% confidence interval. Now, well, technically, depending on what percentage confidence you want, you would change the multiplier according to this formula. So you should have copied these things down the line. So this table is very important. All right. If you want a 95% CI confidence interval, you use 1.96 here. If you want lower confidence, you put a smaller multiplier. The key thing to realize is this form is the confidence interval form. And we explain why it makes sense. If you're trying to make a confidence interval, you're trying to make a statement, an interval. You're trying to create a left and a right interval that will give you some idea of where pi is. And it makes sense to say, okay, I'm going to put p hat as the middle, as the midpoint of my confidence interval. It makes perfect sense because you're trying to say something about the proportion in prediction. What better thing to use than p hat? I wouldn't use anything else. See? So I put p hat in the middle, always. Every confidence interval for pi starts with p hat in the middle. And then there's a bunch of numbers here. Now, I want to ask the class, this together with this, the multiplier times this thing, does anyone remember what that's called? It's 3 words. Yes. Very good. The margin of error, MOE. Very good. Margin of error. This thing is called the margin of error. Perfect. This thing is called the standard error. So lots of errors. Okay. This is called the standard error of p hat. This whole thing together with the multiplier is the margin of error. Very good. And is it clear to the class that the higher confidence you want, the multiplier clearly goes up? That will make your width, the margin of error, rises. All right. Okay, so with this revision in place, I've given out a sheet of paper. I think every table has one, right? Okay, I want you to work on that right now. It really won't take you that long. And when you're done, we will discuss on Scratchpad as usual. Okay. You randomly let me call it up, all right? So we can all look at it together. You are now working actually on this sheet, 12, this one, right? I'll give you a couple minutes to get started with your friends. Then we'll discuss on Scratchpad as usual. I want you to write your answers, same deal, right? Write your answers on the paper with your friends, and later you hand it in at the end of class. Right? You randomly sample 26 Hope students, and you ask each one in the sample if they're born in Michigan or not. And we define a success as yes, you were born in Michigan. You find that 12 said that they were. Define pi, which is the parameter of interest. So let's start with that, right? Before I start, discussing it online on Scratchpad, I want you to start. When you see the word define a parameter, what are the first few words that must always come out of your mouth? So I've already given you the symbol. Pi is the parameter of interest. What's pi? Pi is a long run. Okay, what kind of parameter is pi? Long run proportion. Yes, and when you say good, you must carry on. Long run proportional. What are you interested in here? Look, why is it called a parameter of interest? So pi is a long run proportion of students and whole volume. Yes, that's it. So write that down. So I'm going to put it on. I'm going to start putting this on Scratchpad. Okay. So let me see how well this translates to Scratchpad. Sometimes it doesn't copy very well. Let me try. Okay, let's see. Yeah, it doesn't, FI doesn't transfer very well. I don't know. Okay, So again, I would appreciate it if whoever's ready with the answer, just type in contribute and we'll see, you know. Now, can I just say, these are graded by completion. I actually don't want you to change your answers to, I want you really to answer what you answer. These are graded by completion, not whether it's correct. I mean, of course, it's good if you get it correct, but I really want to know where the class is. So don't feel like, oh, I wrote something else. Now the right answer is here. I'm going to change it. Don't change it, actually. I want to know at this point whether you know these things before we discuss. That's quite important, right? Be honest. Okay? The professor is kind of like a doctor. You don't tell the doctor things that are not true because then the doctor can help you. So I really need to know whether you know these things. So it's graded by completion. So I'm not going to be happy that everyone gives me the same answers from scratch. But what's the point? Then that's just an exercise in creativity. So give me your answers. We will discuss the right ones here. Don't worry. All right. The long run proportion goes to body. Yes, nothing more than that. That's it. And it's pi. Okay. So let's continue. There's other questions I want to talk about. State the VCs which need to be met, and are they met here? Okay, let's try this. Does anyone know? I okay. Every time you see VCs, what? What? Oy. Okay, well, somehow it's. Okay, so it finally copied. So state the VCs that need to be met here. Let me. Well, I'm not going to bother with that bullet point anymore. Okay. Yes, I'll give you a hint. The word success and failure should be there. Why? Isn't this a proportion problem? So successes and failures follow a proportion. They don't come with a mean. We'll deal with means today. But now it's proportions. So success and failure, you need at least 10 successes and at least 10 failures. Now, here's what would be the best way to answer this. You can leave the word successes there because it helps the class remember. But I want you to put in parentheses, what do you mean by a success? You can put 10 successes, parentheses what? What do you mean by a success? Someone, what about the person is considered a success? Someone born in Michigan, being born in Michigan. Yes, something like that. Did you get it? Good. So are they met? Do we have this? We had how many people born in Michigan? See, we had 12. That's more than 10. Since I last checked, 12 is more than 10. And then, which means how many were not? 14. So we meet the conditions, and that's it. So let's move on. The general form for a CI is midpoint plus minus multiplier times standard error. Show what numbers you would plug in here to get a 90% confidence interval. Can you try that? I want you to give it to me this way. Something. Can you give it to me generically first? Using symbols. Don't give me numbers yet. Give me symbols. Something, something, something. Give me a formula. Give me the formula, basically. That's right. What belongs in the center of a confidence interval for pi is p hat. See, I'm trying to make this a thing. You will see this something plus minus box times box, like until you're sick of it. From now till the end of the semester, box plus minus box times box. It's always going to be box plus minus box times box. So what goes in the first box? P hat. That's why I tell you the class is actually going to become much, much, much more plain sailing now because all the hard work is done. Now all those concepts will be revisited 100 times. P hat plus minus multiplier square root. Yes, correct. That's excellent. So now your turn is tell me what this would be specifically if I wanted to make a 90% CI for pi. Can you replace these things with the numbers up? Don't need to give me a decimal. I actually prefer it. Give me a fraction for p hat. Can you give me a fraction? Don't calculate. Give it to me as a fraction. That's fine. See, you want 90% CI? You go with 1.645. Does that make sense? Follow my chart. Okay, I'll flash to that chart. The chart is see 1.645. Excellent. So follow that. And oh, hold on. Okay. So we okay. Yes. Were there 12 people out of 26 that were born in Michigan in our sample? That's peanuts. Okay? And then, like that. This is really good, you know. I mean, this class is always very cooperative, but today is exceptionally good. This is really good. Are you all bothered by this plus minus? No, right? The minus gives you one side and the plus gives you the other side. That's it. It's just a shorthand way of saying two things at once. Okay, show what numbers you plug in. Now, because I want to interpret the CR, I'm actually going to ask you, I mean, do you even need me to do 95? 95 is just change the 1.645 to what? 1.96. Nothing else changes. The data is the same. That's it. So we won't even do that here. I think that's pretty easy. I do want someone to help me calculate. I think this is ready for Desmos, I believe, except for these underscores. I think the underscores are not helping. Whoops, what happened? Hold on. Delete this. Can someone please tell me what this actually is? Okay. What is this? All right. And also, I'm going to introduce a term. This is called the lower limit. I think it's pretty obvious. The lower limit is this. And I also want to calculate the upper limit. Can you give me the numbers for these two? I don't know. Can someone please tell me? Maybe we have checked in the class before. Does Desmos understand if you don't put a star to be multiply? Let me know. All right. Does Desmos accept this without a star to show multiply? Have a look. Thank you. So lower limit is blah blah blah. Upper limit is blah blah blah. What are these numerically? All right. And there's a reason for this. All right. This is going to be less than this, obviously, because this one has a minus sign, this is a plus. So this is going to be bigger than this. The lower limit is, or if you want, you can say left and right, if you want. Left versus right. Okay. I'm going to, because I want this because I'm going to teach you how to interpret your CI in plain English. This is new. All right. Wait, did I not spell interpret correctly? I thought I did. Is it TER? Wow, okay. Thank you. So see, this is one, the lower limit. And let's get the upper one as well. So does Desmos understand non-star multiplication? Or the online calculator that you're using doesn't need a star? Because that's quite good actually. Thank you. Okay, so interpret your CI. Here's how you interpret a CI in plain English. You start with this phrase. We are 95% confident that this is not in the sheet. I'm adding to the sheet. This is not in the sheet. We are 95% confident that what? This is a CI for what? For pi, right? What's pi? Haven't we defined pi? You just literally copy paste. We are 95% confident that the Lawrence born in Michigan is between, and you quote these two answers, this and this. I really hope this makes sense to the class. What are we saying? In other words, this interval, left to right, gives you an idea of where the long run proportion of both students born in Michigan is. Now, I hope you realize this is not a very impressive interval. It doesn't tell you very much. 30%, 62%, pretty wide, isn't it? See? So we will study next time. I don't think we have time today, but in the next class, I'll tell you how could you, because I hope you all realize that a confidence interval that is narrower tells you more. I know it's strange, but I mean, for example, if I said this, the 95% confidence interval of Hope students born in Michigan is between 0 and 1. Am I telling you anything? Every proportion is between 0 and 1. That's like saying everyone in this room is between 0 and 100 years old. It's true, but it's useless. Everyone knows this. So it's like, if I told you the long run proportion of Hope students born in Michigan is some number between 0 and 1. This is me talking like a politician, saying a lot but saying nothing. It's not fake, it's true. The proportion of Hope students born in Michigan is between 0 and 1. Yes, 0 and 100%, of course. But we all want narrower CIs because the narrower the CI, the more it tells us actually. Right? So I'm going to ask the class to guess. What could you do to make your CI more informative and to narrow the CI? Does anyone know what I'm saying? What do you think you should do? And the answer is not that difficult. How do you improve your CI to make it narrower? Does anyone have any idea how? Anyone have any guesses? Oh, that's smart. Yes, smaller confidence. But is that a good thing? Do we want smaller confidence? How do you have high confidence but still be narrow? Anyone have any guesses? This one I'll be very pleased if someone can really guess correctly. How do I maintain a high level of confidence and be very narrow? What would I need to do? I have that answer, yes. If you lower your expectations, if you lower your confidence, your interval will get narrower. That's right. But you have lowered your confidence. And that's not especially appealing either. So how do you maintain high confidence but a narrow interval? Anyone have any idea? Any guesses? Maybe I'll keep it unanswered because I will be answering this question in the next class. I want you to think about that. Right? Is there anything you could do to fix your study to do that? Right? It's not a very difficult question, but I want you to think about it. Okay? Okay, we'll talk all in good time. So I want to talk about this confidence issue again. This is a bit of a revision. In case you didn't understand what I said the last time, this page is new, so I'll have you copy first. When we say confidence, what do we mean exactly? I will tell you again. What do we mean when we talk about 95% confidence? So uh, the statement we just said, we are 95% confident that the long run proportion of hope students born in Michigan is between blah blah blah. Blah. That's one way to define confidence, but it's not a very satisfactory definition. I'll tell you why. Did you realize that I have defined confidence using the word confident to define it? Do you know that's not really a very good thing to do? When you define something, you're not allowed actually to reuse the word that you're trying to define. That's like saying, can you define what cuisine it is? Oh, cuisine is the cuisine of you can't do that. You know that doesn't make sense. You're supposed to explain to someone what the word cuisine. You have to say, oh, the cuisine is like the list of genres of food. You have to use a different way to explain that word. And you will realize that the definition I gave you of what interpret the 95% confidence interval actually reuse the we are 95% confident. So it's not a very satisfactory definition. It will satisfy many people, but what I'm giving here is the technical definition of confidence. Not, I usually tell students this, not everything can be explained in a 5-second TikTok video. Not everything. Not everything worth knowing must be reducible to a TikTok video. Oh, I must say, I know not everybody believes that, but I believe that there is a fraction of people who say if it cannot be TikTok, it's not worth knowing. And that's rubbish. Right? The issue of confidence is unTikTokable. If you want to understand it, it is long and tedious. We've just had Valentine's Day. I always give this illustration. Valentine's Day is a day that you express your love for people. All right. Does anyone like? Let's say you're talking to your significant other, yeah, and then you ask the person like, why do you love me? And the person say, just cause, you know, and says nothing. Do you like that? No. You want a lengthy explanation. In fact, your relationship will start to sour if all your replies are very short. Unless that's your thing. Which I don't think is many people say. But why am I saying all this? The explanation for confidence is a bit like a romantic conversation. It's quite long. It's not clear cut and short in 3 seconds. It's not possible. So let me explain again. If you went out and resampled, let's talk about the Hope Michigan thing again. Every day you go out and take a new sample of Hope students. Keep the sample size, 26 people. Every day you have nothing better to do. You go sample 26 people. You ask, are you born in Michigan? 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 Okay, you get a different p hat. Every day you get a different p hat because some days there will be more people born in Michigan, some days less. All these different p hats, because we know that when you make a confidence interval, the midpoints are always p hat if you follow the formula. The midpoint has to be p hat. P hat, p hat, p hat, p hat. You get what I'm saying? Every day you get a new sample, same size, 26 people. Of course, different people. Okay, if you sample the same people every day, then you're really doing insane things. Right? Why do that? You get different people, but always 26. You get a p hat. Today I had this proportion that were born in Michigan. Today I had this proportion. So you build all the confidence intervals. Different samples yield different p hats. That's the first step to interpreting confidence. All we can say when you say 95% confident is if I had too much time on my hands and I did this sampling thing zillions of times and made so many intervals, 95% of them would cover the true value of pi. But the twist is we never know which CI covers pi or doesn't. It is unknowable. There are many things in life that are unknowable. We can predict whether it will snow tomorrow. But you cannot tell me 100% whether it's going to snow tomorrow or not. It's unknowable. Yes, modeling is getting better. There's a very high chance it might snow or it might not. I don't know. I didn't see the forecast. Right? Sometimes I don't want to see the forecast, but because it's very depressing. You look at your phone, you see snow picture 7 days in a row. Wow, it's switch off, right? Okay, so what I'm saying is exactly this. It's unknowable whether a particular CI. All you have is if I have a zillion confidence intervals, 95% of them will cover pi, but you don't know which. And that's why I say it's like a lottery. Someone's going to win. Someone has to win, or not. The lottery is fraudulent. Someone has to win, but you never know who has the winning ticket. It's something like that. You can buy. All these are like individual lottery tickets. Some will win, some won't. But I can promise you, if you follow that prescription and use the multiplier for 95%, in the long run, all your zillions of intervals, 95% of them will cover the true value of pi. So let me ask a pretty simple intuitive question. I think you all are able to answer this one. Look at my picture again. Which lines are known? I know it looks kind of odd to ask this question. Are the horizontal lines known or is the vertical line known? Which ones are known? The horizontal are known. Good. I made those using the p hats and the formula. What line is not known? Horizontal or vertical? Which line is unknown in this picture? The vertical. It's somewhere, but you don't know where. To teach you the concept of confidence, I had to draw it, but I say this is unknown. This vertical line's position is not known to you. You know why? If you know it, why are you making a confidence interval? Go home. The confidence interval is supposed to give you an idea of where this unknown value is. That's what statistics is all about. You're trying to say stuff about things that you don't know. That's why we don't make confidence intervals for p hat. Why would you need to make a confidence interval for p hat? You know p hat. But you use p hat to make a confidence interval for something that you don't know. That's the point. That's why it's called margin of error. You don't know where pi is. My best guess is p hat, and I go some distance to the right, some distance to the left to give me some leeway to play with. That's why it's called a margin of error. P hat is your best guess, and I move some distance to the right, left, and if you follow the formula I gave you, I can guarantee you that if you did this a billion times, 95% of the intervals you create will cover pi, but I can never tell you which ones did and which ones didn't. That's confidence. All right, and we talked about this the last time. I just wanted to reiterate. So with that in mind, let's have you do another sheet. We'll try to do 3 today. Quite ambitious, but I think this class can do it. Right. This class has been amazing, actually. Very easy. So
Thank you.
yeah, believe me, I've taught classes that are not easy. This one's good. So keep it up. This is an interesting data set, and I always like to share it because it gives me something to say. Okay, so I've given out this sheet. So I want to talk about, and I have it here. I will do it together. I want you to start doing it first. I want you to start doing it first. Then we will discuss it on Scratchpad, okay? As usual. Okay. I like this data set because it's interesting. Okay, so what did this researcher do? And this was published in Nature, which is a top journal, by the way. Okay, he wanted to know, because we know that maybe about 90% of the world is right-hand dominant. So he wanted to know whether that extends to other activities, not just using a hand. So he wanted to know specifically, when people kiss, do they also lean right? You know what this means? Everyone knows what a kiss is. Okay, so it's hard to kiss if you don't, right? Oh, and there's another study we should do, like who shuts their eyes when they kiss. Okay, that's another thing. What is the proportion of people that close their eyes when they kiss? I think that's pretty high. But anyway, um, anyway, so he wanted to know the proportion of people who lean right when you kiss. Because why not? Okay. Now I wanted to look carefully at these words. Can someone, I'm not asking you now, I'm not asking you to tell me what p hat is, okay? The twist is, can you tell me a number that is very disturbing to me? There are many numbers on this page. Can anyone tell me which number is making me very disturbed about this data set? 13. Yes, very good. Look at this. What is this? Okay, I'm going to judge. Okay? I think 13 is too young to be sucking face. This is not. This is not those kisses the mother gives a child on the forehead. Okay, it's not that kind of kiss. Okay? Because you don't lean right for that kind of kiss. Okay. Oh, so this, okay, beyond p hat, this is not even a p hat. This number really disturbs me. All right. Okay. So with all that out of the way, can you tell me if this is a proportion problem or a mean problem? Is it obvious? What are we looking at? Proportion. How can you tell?
Is it right or left?
That's right. It depends on what you are measuring. You wanted to measure whether people lean right or left. It's binary. That makes it a proportion problem. Are you seeing that clearer now? I mean, can you ask other things about kissing? Yes. What angle do people lean? Then you measure. Okay, how many degrees did you turn your head? That, that would make the problem qualitative, and it will become a mean problem. What is the average angle people lean from the axis? Right? Nothing sucks romance out of anything like statistics. I don't know whether you read it. Right? No one said no one ever, right? When things are, getting, you want to say nice things to each other. Let's talk about p hat, shall we? No one does that. Nothing sucks the romance out of things like math. Okay, again, unless that's your thing. But anyway, so long story short, this is a proportion problem because of the question that you asked. Okay, what has happened? Okay, thank you. No, I saw the snow and got disturbed. Okay, so what is the observed stat here and what is its symbol? Okay, the observed stat is not 13 years old. Okay.
Out of 120.
Yes, it's 80 out of 124. Can you type it? What's the symbol for that? 80 out of 124 is not pi, but why? Because it's based off the sample. So the observed statistic is 80 out of 124, which if you want to give me the decimal would be good. I think it's 60 something percent. Right? That's p hat. Good. Define in words the population parameter of interest and give a symbol. See, I'm not giving you the symbol here because I'm trying to test you. Do you know what the symbol is? Greek. Sorry, what? This symbol is Greek, but which is it? Pi. Excellent. Not mu, because this is a proportion problem. So pi. Can you define pi for me? We did it previously for the Michigan case. pi would be, okay, every time you start a parameter, these words should always start the definition. The long run, yes, it's a proportion, not a mean. In this question, it's a,
Couples that lean. People.
yeah, I would say couples.
Couples that lean. Well, kissing.
Yeah, that's right. That is perfect. That's it. How do I know that's the definition? Because that's what I'm talking about. I'm not interested in, as I said, I'm not interested in a mean. I could be, but I'm not in this question. I just want to know what the proportion of couples who lean right when they kiss. That is it. So I hope you can see that the way you define parameters, it's not that hard, you know. You get used to it. First, establish, is it a proportion problem or a mean problem? That's very important. And once you have a proportion problem, yeah, proportion of what? What are you interested in? See, that kind of idea. Okay, very good. What are VCs, and give it, okay, we've done that. What are the VCs that need to be met here to construct a theory-based CI? Okay, can you, see, that's why I always like to scaffold and increment the work from previous things. What are the VCs? Anyone remember? We need to have at least, you need at least 10 people, and don't use the word success if you can. If you must, put parentheses after success. You need at least 10. Yes. Now, here's an important fact. You know that word observational unit that makes people very confused? Do you know the observational units here are not really people, but it's the couple? The sample size isn't always people, because I don't know whether you checked. A couple is two. That's what a couple means. So 124 couples means how many people? 248. You notice the sample size is not 248? The sample size is the number of couples, because you're observing the couple. That's why observational unit is a very important concept. It's not always just how many people are in the room. What did you observe? You observed couples. And so N here is 124. It's not the number of people. There are twice the number of people. It's 248 is the number of people, but we are not interested in that. It's the number of couples because you observed the couple. You wanted to know if the couple lean right when they kiss. Because when you lean right, everyone has to lean right. You can't have one person leaning right and leaning right, then it's not going to happen. All right? So that's the point I'm trying to make. The observation units here are couples. Show your work for calculating a 95% CI for pi. Can you do that? So I will start you off. Box plus minus box. Oy. Okay, that was a bad choice because multiply is the same thing. Box times box. Box plus minus box times box. You know what? Let's speed things up. You don't even need to give me generic. Immediately just give me answers. You can give me a fraction if you want, or a decimal. Fraction is better, right? Yes, you saw 80 out of 124. I want a 95% CI, so the multiplier you should use is, yes. And then what's the formula for the standard error? SQRT, blah, 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 all that, okay? So just type it in. Yes. That's why I always say this, and I'm not saying this because I'm a professor. I'm saying this because it is actually true. Statistics, especially intro stats, is actually not hard. And I'm not saying this because I'm a professor. It is really not difficult if you know how to learn the subject. It's not that bad. It gets better actually. The beginning can be a bit confusing, I agree. But I think this class is doing well. So yeah, that's it. So you know what? To save us some time, I'm not even going to ask you to calculate this. I'm just going to say the lower limit is, I like this one, star, 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 some number. And the upper limit is, okay, star, star, star versus star, 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 star. All right? So can you interpret what your interval is? We are 95%. Okay, I'll copy these words. When I ask you to interpret interval, here's the layperson one, the one that's not so accurate. I would stop it. Okay. We are 95. Okay. Can someone copy paste a phrase? We are 95% confident that is between star, star, star and star, 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 star. What is the thing that you're confident is between star, star, star and star, 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 star? right? Can you find a phrase in the work that's on the scratch pad already and just, yes, the 95% of the long review of the case is between, why am I doing this? I mean, partly why I want to make this class laugh is it helps retention a little bit. It does. Okay. It's quite high stakes. When a professor makes a joke and if no one laughs, it's always quite high stakes. It's for the professor. All right. But I'm doing it to help you learn. And basically, when you're not what? That whole phrase, Lauren, Verona, couple of leader the case, that whole thing is fine. That's fine. Put it in. We are 95% confident that that thing is between star, 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 and star, 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 whatever those numbers are. That's it. Now, let's now do the last part. I don't really enjoy this layperson definition of confidence. You see, interpret your interval. Confidence interval, you use the word confident. I don't like that kind of thing. So let's do the non-TikTok interpretation. This is quite important for you to get. What does 95% confidence even mean? Now, I'm quite confident this class can get all the blanks. I have quite a, I feel this class, the level of understanding is quite good. If we took zillions of sample of size what? Okay, give me a number first. Remember, when we talk about confidence, we replicate the study many, 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 many times. Can anyone tell me what number goes here first? In this study, what was the original? That's right. In other words, if I every day went out and looked at 124 kissing couples, right? It will give me a crazy impression, but that's besides the point. Okay, we would get, if I took samples of size 124 every single day, we will get a variety of values of what? What is the thing that I would measure every day? What is the thing that would be different each day? The sample size is the same. I every day go collect sample of size 124. I go and observe 124 couples. Until I get 124 couples, I won't go home. Right? I must collect 124 kissing couples. What did I get every day? I will get a variety of values of, yes, their results. Can you give me a symbol? What is the thing that I get a variety of? Yes, p hat. It's actually in my notes, right? You would yield a variety of p hats. Yes. We could then potentially calculate zillions of different what. You use the p hats to make what? What are the things that you get zillions? Okay, there are zillions of p hats basically, and the zillions of p hats will yield zillions of different what? What did you use the p hats to make? Not p-value. So what is the thing that you can generate? Go back to the picture. Remember the picture I drew? What are the zillions of things that you can generate from the zillions of p hats that you get every single day? That's actually the more difficult thing. Each one using p hat as the midpoint. That's very good. What are the things that you have made? What things use p hat as the midpoint? Yes. You can then make zillions of different CIs. You can shorten the CI if you want. You can make different CIs, all of them using p hat in the middle. But in the long run, 95 of these zillions of CIs would, what's the phrase I want? What about these zillions of CIs? Confidence means in the long run, all these zillions of intervals that you make, 95% of them would. And what's the phrase? I'm not saying whether you know that has happened or not, but we can guarantee you that they would. What about these CIs? Right? That is very key to understanding what confidence is. You go out every day, you sample of the same size, you go calculate a different CI every day. Would cover pi. You want to make the answer even better? Cover the unknown pi. If you want to reiterate the fact that we don't know what pi is, very good. However, we never know if, this one would really please me if someone dares to fill in this one. However, we never see, we are saying in the long run, 95% of these zillions of CIs would cover pi. However, we never know if, and the answer is actually in a previous slide of mine, if you can pick up on that. Yes. we never know if a CI does cover pi or not. This is actually what confidence is. Saying we are 95% confident that pi is between this and this it's kind of like the answer you give a child when the child asks something. You know, some children are very precocious. They say like, you know what I'm trying to say. You're trying to simplify something for a child. So you don't lie to the child, but you don't tell the child actually everything that's what's going on. You don't tell lies, but you simplify the answer. This is kind of this is the grown-up answer. This is the child answer, something like that. However, we never know if a CI, and you know, to really drive the point home, if any particular CI, very good. That's it. Excellent. So this gives us to be in very good position to continue our notes, and we're going to move to a mean. And don't panic, because when you go to a mean, all these things of marginal error, standard error, all these things are the same, but now we're talking about a mean. So you know that a mean, population mean is mu, not pi anymore. Mean, m, mu. And again, we have dealt with testing hypotheses about mean. You should have seen this if you've taken the exam, right? Mu is 8, mu is less than 8, things like that. You've seen that. So now, we want to teach you how to make a confidence interval, not for pi, but for mu, for another parameter. Pi was what the first half of today was all pi, 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 pi. Now it's mu. Again, it's a theory-based approach, so there is a validity condition. Does this sound familiar to you? Sample size at least 20, not too skewed. Have you heard that before? You should have. Of course. Can anyone tell me why success and failure hasn't shown its head here? Why am I not talking about successes and failures here? Why has it changed? Why am I now talking about at least 20 and not too skewed? Because the parameter I'm interested in is a mean. Means have nothing to do with successes or failures. Because the fact that you're interested in mean means you have asked a quantitative question. How many hours did you sleep last night? How is that a success or failure question? You don't say yes or no, you give a number. There's no success or failure when you have a mean. And that's why the language is different. Now, the best part, but sometimes it can be a bad thing. The formula is actually very similar to the p method. The CI, okay, first of all, remember the expression I told you, multiplier times standard error? This is the mean version. The standard error formula is actually simpler. Just take S, standard deviation over square root n. It's even easier. It's not that square root pi 1 minus pi, no more px for now, right? Actually, for the rest of the day, no px for the rest of the day, all mu stuff, okay, x bar. This is the expression for the standard error of x bar, and you dump the standard error inside. Basically, the margin of error is always multiplier times standard error. It's just which standard error you use depends on the statistic that you're interested in. If you're interested in the mean, you use s over root n for your standard error. That's it. Notice p hat has disappeared. Why? I'm not talking about a proportion. I'm talking about a mean. And if I want to say something about a population mean, I will use the sample mean as the midpoint. So when you study, the way to study successfully, not just math, anything, is to make links. What do I know already and what's new? Yes.
You use the same multipliers.
That's see, one sign that a class is tracking what you're doing is they ask you questions 1 or 2 seconds before. I'm just about to bring it up. Where do you think this multiplier comes from now? That's a good question to ask you. I'll give you a hint. There are 2 tables you have learned. There's a z table and a p table, right? Can you guess? Where do you think this multiplier is going to come from? I think I heard the right answer being whispered. What is it? When you dealt with the mean the last time, what table did you use? P, and that would be the case. You would get, so to answer Reagan's question, you would get the multiplier from the T table. Here's another question. Does a T table have a degree of freedom? You better say yes, right? T tables have a degree of freedom. Can anyone guess what the formula is? How many degrees of freedom should I be looking at? What's the rule that you have learned with me? N minus 1. Yes. So let's complete our notes. Depending on the confidence, well, that's very small. Okay. Depending on the confidence level, we would change the value of the multiplier. And we obtain the multiplier from the T table. You use n minus 1. And all the old rules apply. If any particular DF is not available, you round down. Same rule. So I hope that answers your question. You go to a T table. Now I'm going to show you right now how to do this for our class sleep data. So let me call up our class scratch pad for that. Hopefully I can get it. I think our class data scratchpad is here. Okay, let me open it up. Okay, I didn't want to do that. I want to open it in a new tab. Okay, so here it is. Let's hunt for our class sleep data. I believe, okay, sleep times. Okay, I am going to copy this over to Scratchpad, okay, so we can deal with this. So here we go. And I'm going to paste this here. Okay. Okay, I have just pasted our class sleep data onto a Scratchpad, okay? I'm going to teach you how to use this formula. Okay, so if you go back to my slides, see, I gave you this formula, x plus minus multiplied, right? We're going to use that. We're going to use that right now. Okay, so here's the formula. I'm going to reproduce it here. We know that, okay, let's get, okay. We want to construct a 95% CI for the mean sleep times in hope. I'm going to assume this class is representative of hope. If not, it doesn't make sense. It's not true. This class is not representative of hope. This class is 90% female. So it cannot be representative of hope, but I'm just going to pretend it is for pedagogical reasons, okay? So we want to construct a 95% set of mean sleep times in hope. How do we do that? You know that the generic formula is x bar plus or minus multiplier times s over square root n. You get it? It's from my notes. Don't I already almost have everything? X bar is here, S is here, N is here. So let's just finish. The only thing of difficulty now is to show you how to get the multiplier, which I'm going to do now. Now, what's the rule? We know that the multiplier, I'm going to ask you to fill it. This is a multiplier from T table with DF what? Anyone care to fill that in generically? What's the rule I just taught you? N minus 1. So you need to go to the DF of n minus 1, which in this case is how much? 19. What's 20 minus 1? I can't believe I'm saying this. What's 20 minus 1? 19. So go look at 19. Okay, so where's our T table? So the T table is here. Okay, so okay, now you have to concentrate a little bit because this is new. Not the degree of freedom. That's okay. So go to 19. Okay, I'm going to highlight this whole row as usual. Okay, first of all these numbers are the multipliers that you need. Not all of them, but these are all potential multipliers. Okay. Also known, aka critical values. You might see this word critical value and multiplier are similar. Why are they called critical values? Because they're critical. They're important. Multipliers are important. So why do I say all of these are potential multipliers? Because if you want to make a 95% confidence interval, so really listen up, it means the center part needs an area of 95%. Now, here's my question to you. I know this picture is a right side picture. Right side. Can you answer me this? If the middle is 95%, what does that leave your right side area to be? Right side. If your middle is 95. If your middle chunk is 95%, your right side is left with how many percent? Is it 5 or 2.5? The right. 2.5. Why? 95 in the middle leaves 5 on both sides total, which means one side, right side, 2.5%. Go to 2.5%. Column 3 is going to be very important from now on because a lot of the time you are asked to construct 95% CI. So if you want, you can actually highlight column 3. That might actually help. But remember, column 3 is the one you use for 95% CI. If I ask for a different CI, you need to think of. Let's do one more. If I wanted a 90% CI, all right? Middle area is 90, which means the right side will be how much? If the middle is 90, the right will be 5. Then you would transfer to 5, column 2. Do you understand? So in this case, you go to 19 and column 3. What is the multiplier? Anyone get it yet? At 19 degrees of freedom and 2.5, do you see it? I do. Can you paste it on Scratchpad? I don't want to tell you what it is. I want to see if you can pick it up. What is the correct multiplier in this case? All right, so let's start another line. You know X bar is 7.2. I think I'm going to fill that in. That's pretty easy. 7.2 is your class mean sleep time. But what's the multiplier? Just give me the number from the table. If you saw it correctly, I memorized it, so I'll be able to. Yes. Did you see 2.093? That's the one. And then just continue. Fill in what is S and square root N and all that. That is it. That okay. Wow. Okay.
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 Who's yawning?
No, because it sounded like that hurt.
A little maybe.
Yeah. These are hard. Okay. So you have this times. Did you see S on the screen? You don't have to type the whole thing. Okay, just a few decimal places is fine. I think everyone kind of knows where that comes from. Yeah, that's right. And then what was the sample size? Divided by SQRT of? Every time I see this, I'm reminded of, isn't there a brand of, what do you call it, soda or pop? I can't, okay, soft drink called Squirt. Isn't there one called Squirt? Is it orange flavored? And it's a green bottle, am I right? Oh, okay. What does it taste? I'm not a soda drinker, so I don't. What does it taste like? Oh, like Sprite. Is Sprite still a thing? Okay, so Sprite's still a thing. Squirt's a thing. Is 7-Up still a thing? Yeah. Oh, it is. Okay. Ooh, there's one I really can't stand. Dr. Pepper. I don't know what else it is. It tastes like cough syrup to me. But some people swear by it. They love it. I don't know whether they're addicted to it, but anyway, okay, squirt, okay, 20s, okay, that's it. So that is it. That is how you make a. So if you went to your, I think my slides have some pretty generic things. Okay, there's nothing for you to copy. We have done it on Scratchpad already. When you want to make a confidence interval, get all these ingredients down: X bar, S, and degree of freedom, and -1, and then you just use this formula, box plus minus box. Okay, here I've broken it down a little bit more. You know how to interpret confidence intervals. You're 95% confident that parameter, long run mean, all is between this and this. Nothing new. Exactly the same. And we're going to do a third worksheet in a minute. There's one last thing I want to teach you. I have not shown you how to make any charts in Google Sheets or anything yet. And I think I'll be doing you a disservice if I didn't do that. So I'm going to do that. All right. How do you make a histogram? Because you know why? You need to check for skewness and all that. I need to teach you how to get a histogram. So I'll show you now. So let's illustrate. And I'm also going to make a YouTube video about this, and you can check it out later. I haven't done it yet. I've been so busy, but I will. But I'll show you now. All right. So if you want to make a histogram for our class sleep data, here's what you do. You just go and select just select the cells for which you want to make a histogram and do nothing else first. Select them. You actually go to insert chart. See, AI, so clever. They know what you want. It even picks the right chart for you. You don't even have to pick the right chart. It knows that data like that should be in a histogram. You need to do nothing else. Histogram, done. Was that easy? Select cells of interest. Go to insert chart. Everything else is done for you, right? So, do you know when statistics was taught many years ago before computing? Students would actually learn how to draw histograms by hand. It's pretty tedious. You have to measure the data and okay, have a look. See, why is a histogram useful? And if you can, you can change the title, you can add, you can play around with this axis title. Okay, I will leave you to, I think that one students can figure out on their own. Okay, so if you look at this, what does this tell you? Is our class data skewed? You better say yes. Right? Don't be afraid, it's very skewed. So did we meet the VC to do it? Actually, no. We actually don't. We actually were not authorized to make our conference info because this class data is very skewed. Did we have 20 people? We did. We just met that. We did have 20 people exactly on the nose, 20. But this data is super skewed. It's not bell-shaped at all. It's very skewed. It has a heavy tail on one side, so didn't pass the skewness test. So uh, you know that thing, the check mark and the X and all that, yeah. So you can think of that. Yeah, we didn't meet the skewness condition. Very good. So I think we're in very good time to actually finish a little bit early today. Here's one last thing I want you to do. The twist is this. I will give you the data on Sketchpad. Let me paste the data onto Sketchpad so you don't have to type it. I want you to work on this one. Again, we'll do the same thing. You do it first on paper, then we will discuss it together. You know what I want you to do? I will paste this data on the spreadsheet. I want you to privately in your own group, make your own Google Sheet, draw a histogram of this data, not our class data, this data which I will give you. Don't do it publicly on the shared data spreadsheet. I'll put a data there. I want you to make a histogram and to prove to me that you know how to do it, email your histogram to me. Just do a screen capture, paste it. You don't have to type anything in the email. I will know what it's about. Just paste the histogram that you make onto your email to me. One group, send me one. That's enough. All right. So the data is coming. Let me get the data for you. Okay. Uh, okay. The data. Okay. I think yesterday I got the data in a more convenient location. Let me just get the data out. Okay. Uh, Okay, let me get to the correct. Sometimes Google Sheets behaves in a very bad way. Okay, I have the data in the here. Let me. Okay. Now I want to see if anyone in class remembers how to get the statistics that you need. If you can't remember, I will revise it, but I think some of you can remember. Okay, I'm going to call this put your records on because okay, so if you go to put your records on, do you all know this song? Okay, so your records on, yeah, that's the one. Anyway, yeah, go put your records on, but after class, okay? Okay, but put your records on is quite a famous song, and you know what these people did? They played 17 seconds of put your records on to people and asked people how long do you think that was? This is a much better study. You know why? They picked an ugly number 17. Don't pick 10. Everyone's gonna guess 10. So they picked 17, and here are the answers. Some people, well, that's awesome, thank you. But can you actually don't pick, okay, be honest, okay? Make it yourself. Don't just take this and paste it into your email. I want you to make it yourself. I want you to learn how to make this histogram. Thank you. Whoever pasted this, thank you. But I want you to make it on your own. Call out your own non-shared Google Sheet. You can copy this data, obviously, so you don't have to type it. But make your own histogram and send it to me. So let's talk about this histogram if you like. Is it quite skewed? Yes, it is quite skewed. Let's ask the class, do you guys remember how to get X bar, S, and N? Okay, N is pretty easy. You can tell me how many people are in this data set without asking the computer. But does anyone remember the command to get X bar? What is the command in Google Sheets to get memes? Anyone remember? You don't, it's okay. I'll tell you in a minute. But I think some of you may remember. It's not meme, unfortunately. It's another word for meme. It is average. Very good. So how do you do that? So let me revise. You go to an empty cell, equal, don't forget equals, average, put a parentheses, and then you select. Select the cells that you want to average. And then hit enter. I don't know why. No, no, don't do that. Okay. So that's the mean. Good. Now, does anyone remember how to get the standard deviation? What's the phrase for that? What's the command in Google Sheets? It's the same as in Excel, by the way. It's not squirt. Anyone remember? I did try to pronounce it last time so that it can stick in your mind. It's unpronounceable. Well, in English anyway, it's unpronounceable. What is it? 5 letters. Anyone remember? What is the function that you need to use in Google Sheets to get standard deviations of data? Yes. Remember? Right? Right? STDEV. So can someone do that? Show me that you know how to do that. Go to the scratchpad and equals. Go to the empty cell and type. Right? Get the standard deviation of data. Now, yes, that is the STDF. But if you want, you can put it here. Okay, good. Uh, how many people are in this data set? Is it easy to tell? Can you tell? Please. All right. Just put it in, just for completeness. All right. And actually, I do ask you to report these things. Plot a histogram, which you're supposed to email to me. Report X bar, S, and N. Well, here they are. Okay, we have just gotten software to get these things for us. Okay, I want to talk about B and all that. Okay, so start working on the other things. Describe the parameter. I am interested. Okay, first of all, is this a mean problem or a proportion problem? What kind of data do we have? Are these yes or no questions or not? These are qualitative, which means you're interested in a mean. Good. So that battle is won. Do you know the mean symbol is? The long run mean must be mu. So when you define something, you kind of need to tell me what it is, right? Mu is the long run mean. What every time you say the word mean, there must be some quantity. What are these things? Actually, I didn't tell you what is the. Oh no, I did tell you. They played. How long was the snippet they played? 17 seconds. So these are times in seconds, right? So I'm giving you a hint. Can you define mean properly? Can you define mu properly? Let me actually get the let me get the assignment out so that uh, we can actually discuss it. So the assignment is here, I believe. Yeah, it is. Okay, let me, because I want to discuss this and we're out of here already. That's it. Okay, so plot a histogram we have done. Okay, so here are the questions. And let me go to our scratchpad. Okay. Okay, so I'm going to call this, put your records on. Okay. Okay, plot a histogram, report X bar, S, and N. So we have done that. I don't think we, okay. Okay. Okay, we are on B now. Anyone want to try? Describe the parameter. We know it's mu, good. And we know mu is long run mean what? Okay. Can you finish this thing carefully? I would be very pleased if someone can define this correctly. What were you measuring? every time we define a mean, there has to be some quantity after the word. What is the thing that was actually measured? It's not very hard, but see if you can get it. Eh? It's not that hard. Anyone want to try? What were you measuring for people? Okay, I like that answer because it gives you a chance. Okay, this sounds like it's correct, and thank you, please. Okay, but it is not exactly what is the correct definition. Leave it there. I'll get you try again. Leave it there. It is. It's not. Yes, we are interested in the accuracy of estimation, but that is not what was measured. So just leave it there. But can you modify this answer? What was measured? Can anyone care to define the meaning slightly differently? It is about length of snippet. Actually, it is. The word length of snippet should be there. But what about the what? How would you phrase this more correctly? I would say. See, see, when you say mean of students, do you notice that you didn't say mean what? You didn't say mean what? The word mean has to be followed by a quantitative thing. What what is the quantitative thing that you measured here? What are those things? The 6 and the 7 and the 9. What are those things? Okay, good. We're getting closer. Will you need the phrase could accurately estimate actually? Did you care about that? Okay, it's forming and I'm very excited. Good. It's the long run mean of seconds. Student, yes. If you don't like using the unit, you can say the mean time parentheses seconds. But you can say seconds, that's okay. The long run mean number of seconds students estimate the length of the song snippet. Yes. Now that's not easy. So you can pat yourself on the back. This is not easy. Getting X bar and all that it's actually easier. This kind of thing actually shows whether your thinking is clear or not. So it's not about did you estimate the length accurately? That's a yes or no question. This is just, I don't care if you're accurate or off base or whatever. Tell me how long you thought the snippet was, and mu is the mean of that time. The long run mean number of seconds students thought the snippet was. Very good. So give this a good careful think when you go back home and think about the problem. Can I have this one? Verify the VCs. Are they met? Right. Can someone specify? We need at least. Okay. So you needed to have at least 20. What's the word we want? Observations. If you like, don't say successes and failures because this is not a proportion problem. You needed at least 20 observations. You can put in parentheses, we had how many? Make it clear for people. You can put in parentheses, we had, actually, how many did we have? I think we had, let me see, 25. That's right. We did have 25. So that's okay. And those observations should not be skewed. That's right. But were they skewed? Data should not be too skewed. Did we fulfill that one? I don't think we did, right? Because if you look at the histogram that someone kindly pasted here, oh, it's gone. Okay. Okay, never mind. You should have made the histogram. I think it was pretty skewed, the one I saw. Okay. So you know what? To help in the learning, I think it was this class. Someone taught me the last time. I'm going to try to do this. So I'm going to get I think, colon, check. Yeah, see, I remember. Okay, I don't want an emoji. I want this one. Wow, there's a chess pawn, really? I don't know what that's for. Shall we have some fun? Let's do this one. Okay. Whatever that means. Okay. Okay. The data should not be two scale. This is not fulfilled. Okay, this one I want the cross. How do I get that one? Colon what? Let me see. Actually, I want to learn actually. Let me see. This is not. Wow. Okay. Well, let's do this one. Okay. I see. Comet falling down. Okay. So not fulfilled. Okay. Very good. Construct. You know which one I really like? Okay? And one day I'm gonna try to. You know the sleigh one. I love that one. Putting nail polish. Okay. That one's my. I'm not so with it. I had to ask my niece like what that meant. She said it just means sleigh. I said yeah, I know what sleigh means, but why? And she couldn't tell me. Maybe you can tell me why is it putting nail polish is slaying? Like you're slaying the you're doing really well. Why nail polish? I don't get it. That's all.
Wait, you really want to know?
No, no, I really want to know.
Oh, it's just like, so I, let me break this down. Sorry, I think it's like when a girl gets her nails done, she feels like
I
elevated.
see.
So like the emoji of like doing your nails is like symbolic of that.
Oh,
Slay.
hooray. Oh, I, I get it. Okay. Okay. So, oh, okay. Wait, but this is a different one. This looks like piano keys. I'm talking about the one where you can see the nail polish applicator thing. You know?
iPhone.
Okay, okay, never mind. Thank you. I no, I wanna know. I wanna know. This is the most satisfying explanation I've ever had. No one can tell it to you. That was really good, actually. Now it makes sense to me. Okay. Construct. Okay, let's finish this and then be done. Construct a CI, 95% CI and interpret. Okay. So what is the generic X bar? And you can finish it. Okay. Okay, let's do generic first because this is quite new. Let's see if we can write generic first. X bar plus or minus multiplier times. What is the standard error expression? It's a simpler one actually, this one. S over script n. That's right. So to make it a little bit more complete, I will always say the multiplier comes from the which table? P. Very good. With how many DF? Very good. So let's do that. So I don't think you need me to oh, we haven't actually reported the export and all that here. So you know what? To help you guys, I will do it. Okay, I will move this here, Control C, and then unlink. Okay, this should help. Okay, so can you now put the numbers in? Okay, and get me the correct multiplier as well. There, the DF is all there, the guide is there. Put your multiplier in, then we'll check and see that's. You know what would be a song cooler than put your records on? Get your T table out. Wouldn't that be nice? I wonder whether that song will be successful. Let's get your T table out, your Z table out, instead of putting your records on. Okay, so yes, so X bar is 13.8, S is that one, square root 25. You should be using a DF of, I know it's pretty easy, but you can fill it in. You should be using a DF of uh, 24 because 25 minus 1 is 24. Is that available? I think 24 is there. So you know what? To make it complete, let's not erase this. Let's not erase this. Let's just start another line. Okay, you fill in the correct multiplier here. Okay, let's give it a check. So you say it should be 2.064. Let's see. Thank you. Let's see. So you should be at 24 degrees of freedom. And we are interested in 95% CI. You know it's column 3. I've told you. Column 3 is very important. 95% CI, 2.5% area. So 2064. Did you see that? So 2064 is correct. So that's right. Now, I do want someone, and we are going to answer one last part. I do want someone to calculate the actual number. You know what? It will make it easier to talk about this. I don't want to use stars now. Can someone get the lower limit and the upper limit as well? All right. Because I'm going to use it to answer the last question. What's the lower limit and what's the upper limit? And then I'm going to ask you all, how do you think you can use this to answer the last question? To answer this, you need your confidence interval, you see. Oh, we didn't interpret it yet, right? We are 95% confident that we'll use the layperson one, right? Not the long one. We are 95% confident that what is between what and what. Can you finish the sentence? Thank you. Right? That's the lower limit. And that one's the upper limit. Good. So can you can you interpret the CI? Then we'll answer E and then we're out of here. Right? What is the CI's interpretation? This is the layperson one, the easy one. We are 95% confident that what is between what and what. Again, go copy paste, okay? I actually promote copying and pasting because that means you know what should go there. Right? There is a phrase you can copy and paste. Oh yes, thank you. Can you move that away? We are 95% confident that the long run mean of second students estimated rank on the song snippet is between, yes. And you don't have to quote all the decimal points, just a few, right? It's between 11.56 and 16 point whatever seconds. Very good. So can you use this to answer part E? Based on your CI, do you have evidence that on average students cannot accurately estimate the length of a 17-second song snippet? How would you answer this question in light of the confidence interval? Can just answer me this. Do you think students on average can estimate the length accurately? I see you're shaking your head. That's correct. You say no. Can you tell me why? The answer is no because why is it linked to the confidence interval? See, that's the whole point of statistics is not to use anecdotal evidence. You can't say, well, because 13.8 is way below 17. Yeah. How far below? You see, use the confidence interval to argue. Why do you say that they can't accurately estimate on average? Because anyone know the answer? Why do we say, yeah, I don't think they can on average? Because look at the confidence interval carefully. Anyone care to finish that? Where does the confidence interval start? The lower limit is 11.5. It goes all the way to, because the upper limit is less than 17. 17 is outside the interval, which means on average, people cannot tell quite accurately. See, 17 is the actual length. But the whole confidence interval, which gives you a list of reasonable values from you, is outside 17. So you can say that no, they can't seem to tell on average because 17 didn't even make it into the interval. Did you get that? Okay, thank you very much. I really enjoyed this talk. I'll see you all on Thursday. So just hand in your sheets, just one bunch together. You don't have to separate them. Just put them